Now let us have a look at a couple of examples or exercises of how we can calculate probabilities using a PMF, a valid PMF. Alright, so the first exercise, it's question 11 in your textbook. It says, let x, or random variable x, be the number of students who show up at a professor's office hours on a particular day. Suppose that the only possible values of our random variable x, it's 0, 1, 2, 3, and 4. So you could either have 0 number of students, 1 student, 2 students, 3 students, or 4 students. And suppose that the probability of observing x equal to 0, that is 0.3, probability that x is equal to 1, 0.25, probability that x is equal to 2, 0.2, and probability that x is equal to 3 is 0.15. And so the first question is, what is probability that x is equal to 4? Alright, so since they tell us that we only have possible values 0, 1, 2, 3, and 4, and we're given here probability that x is equal to 0 as 0.3, probability of x equal to 1, 0.25, of 2, 0.2, and 3 is 0.15. And the last probability that's missing there is probability of x is equal to 4. Alright, so for any valid PMF, we have two criteria here, and both of them must be met. The first one is that all probabilities must be greater or equal to 0, so must be positive. And the second one is that the sum of all probabilities must add up to 1. So if we have a valid PMF here, or to make it a valid PMF, we know that the probability must total up to 1. And so P4 then will be equal to probability that x is equal to 4, or you have 4 number of students who show up during office hours. And so that is equal to 1 minus 0.3 plus 0.25 plus 0.2 plus 0.15. And so that probability is 0.1. So P4 is equal to 0.1. B, draw both a line graph and a probability histogram for the PMF of random variable x. Alright, so start with a line graph illustrating the PMF of random variable x. On the y-axis, you have your probability values. On the x-axis, you have your possible values for random variable x. And we see that we have possible values 0, 1, 2, 3, and 4. And the probability of observing x is equal to 0, that is 0.3. So a line graph, or a line corresponding to x equal to 0, looks like that. And the probability of observing x equal to 1, that's 0.25. And so we'll say it's a line that goes up until there. For x equal to 2, a line that goes up until correspond probability of 0.2. For x equal to 3, we have probability of 0.15, and x equal to 4, probability of 0.1. So that is a line graph. Now, probability histogram is similar to the line graph. It's just that instead of lines, we will have columns or bars. Okay, so the probability then of observing x equal to 0 goes up to probability of 0.3, probability of observing x equal to 1, 0.25, probability of observing x equal to 2, 0.2, probability of observing x equal to 3, 0.15, probability of observing x equal to 4, 0.1. Okay, so you see that they look similar. It's just that with the line graph, you literally have lines, vertical lines, and with probability histograms, you have bars. Cool. You may do the rest of question 11, C and D, to calculate probability. Now another exercise is question 13 that says a mail order company business has 6 telephone lines. Okay? Let random variable x denote the number of lines in use at a specified time. Suppose the PMF of x is as given in the table below. So in the table below, we have possible values of random variable x, which is 0, number of lines in use, 1 line in use, 2 lines, 3 lines, 4 lines, 5 lines, 6 lines. And you have probabilities for each of these possible values. Now we need to use our PMF to calculate the following probabilities. Before we start calculating the probabilities, let us have a look and see if this is a valid PMF. Okay, so we see that all probabilities are greater or equal to 0. So the positive, the greater or equal to 0. So it's one of the two. So we see that they're all greater than 0. Good. And then if we add up all the probabilities, 0.1 plus 0.15, 0.25 plus 0.245, plus 0.25 plus 0.2 plus 0.06, 0.96 plus 0.04, which will add up then to a total probability of 1. So if you add up all probabilities, you should get a total probability of 1. And so we see that both criteria are met, and so this is a valid PMF. Alright, how can we then use this PMF to calculate the following probabilities? So for A, we need to calculate the probability that at most 3 lines are in use. B, calculate probability that fewer than 3 lines are in use. C, probability that at least 3 lines are in use. D, probability that between 2 and 5 lines inclusive are in use. And E, probability that we have 2 to 4 lines that are not in use. And F, we have at least 4 lines that are not in use. Okay, so firstly, before we calculate probability, let us look at the keywords. These keywords will guide us in letting us know the possible values for our random variable x for each of these questions. So for A, we're looking at the probability that at most 3 lines are in use. So the key word here, or keywords, is at most. At most 3, meaning 3 is the threshold or the maximum possible value, right? So in this case, we have x less than equal to 3 for A, which means that we're looking at possible values x equal to 0, 1, 2, up until 3. Alright, B, fewer than 3 lines. Fewer than 3 lines sounds like x less than 3. And so we're looking at x equal to 0, 1, and 2 only. So values that are less than 3, or x values that are less than 3. C, probability that at least 3 lines are in use. So at least 3, meaning 3 is the minimum. So it's 3 and upwards. And so we're looking at x values 3, 4, 5, and 6. And then D between 2 and 5 lines, inclusive, are in use. So between 2 and 5 lines, and so we have x equal to 2, 3, 4, and 5. And then E, 2 to 4 lines that are not in use. So if 2 lines are not in use, that it means how many are in use? If we have a total of 6. So if 2 are not in use, then 4 are in use, right? If 3 are not in use, then the other 3 will be in use. If 4 are not working, then 2 will be working, right? So we're looking at here we have 2 lines that are working, or 3 lines, or 4 lines. So if 2 lines are working, it means 4 are not working. 3 lines are working, it means 3 are not working. 4 are working means 2 are not working. So that's a 2 to 4 inclusive not working. Okay? So it must make sense. Then for F, at least 4 lines are not in use. So if 4 lines are not in use, at least 4 lines are not in use, it means that at most 2 will be in use. So if we have at least 4 not in use, then it means that at most 2 would be in use. And so we're looking at possible values, x equal to 0, 1, and 2. Now, how do we then calculate this probability? For A, the probability that x is at most 3, we will write down, firstly, we have capital P bracket capital X less than equal to 3. This is equal to, we're looking at possible values here, x less than equal to 3. We saw that it's x equal to 0, 1, 2, and 3. And so the probability is P0 plus P1 plus P2 plus P3. And that is equal to a probability of 0.7. Probability that x is less than 3. Which values of x are less than 3? It's 0, 1, and 2, right? So the probability is P0 plus P1 plus P2. And that probability is 0.45. Probability that x is at least 3 or greater equal to 3. Which values of x fits this criteria? It's 3 plus 4 plus P5 plus P6. And that is equal to 0.55. Probability that between 2 and 5 lines inclusive will be in use. So capital P bracket capital X in the middle, greater equal to 2, less than equal to 5. Which values of X are between 2 and 5, including 2 and 5? It's equal to P2 plus P3 plus P4 plus P5. So the probability there is 0.71. Now the probability that between 2 and 4 lines inclusive are not in use, we saw that probability, we write it as capital P bracket minus X greater equal to 2 less than equal to 4. It's equivalent to having X being greater equal to 2 less than equal to 4. And so that probability is P2 plus P3 plus P4. Since the values of X that fit this criteria, it's 2, 3, and 4. And so that probability there is 0.65. And then lastly, the probability that at least 4 lines are not in use. So if at least 4 are not working and we have a total of 6, then it means that we have at most 2 that are working. So if at least 4 not working, it's equivalent to at most 2 are working. You can also work this out as 6 minus x. If that's greater or equal to 4, then you have the negative x greater or equal to negative 2. The moment you multiply or divide by a negative number, it changes the signs, right? So you have x less than or equal to 2. That's why I have the probability that x is less than or equal to 2. And so the values of x that fit this criteria is equal to x equal to 0, x equal to 1, and x equal to 2. And so this is equal to P0 plus P1 plus P2. And that again is 0.45. Cool. Now question 17 says a new battery's voltage may be acceptable or unacceptable. So you either have this or that. Okay? Acceptable or unacceptable. A certain flashlight requires 2 batteries minimum. It requires 2 batteries, okay, to work. So batteries will be independently selected and tested until 2 acceptable ones have been found. So you will independently select batteries and you will test them until 2 are acceptable. So suppose that 90% of all batteries have acceptable voltages. Now let random variable y denote the number of batteries that must be tested, or the number of batteries that must be tested until we have 2 acceptable ones, right? So you must get to the 2 that are acceptable. You cannot just test things and then not know what the outcome is. You must test until you get 2. So the moment you have 2, you put those 2 in the flashlight, and then you continue again. You find other 2 that are acceptable, you put them in a flashlight, and then you find other 2 that are acceptable, and so on, right? Okay, so now the question is, what is P2? That is probability that y is equal to 2. Y equal to 2, meaning that we have tested only 2. So we have tested 2 batteries, and so we found that those 2 actually are acceptable, right? So you test until you get 2 acceptable ones. So if we only test 2 and we have 2 already, then we assume that those 2 are acceptable. Otherwise, you continue testing, right? Okay, so probability. Firstly, before I calculate probability, let us do then a tree diagram. So from a tree diagram, you either have a battery that's acceptable or not acceptable. The probability of having an acceptable battery is 0.9. Probability of having a battery that's not acceptable is 0.1. So let's say the first battery is acceptable. Now you need to continue the experiment because you need 2, right? Your flashlight makes use of 2 batteries. And so the second one could be acceptable or not acceptable. The moment then it's acceptable, you have your 2, then you're good. You can put them in your flashlight and then look for the other ones. Okay, so now the probability again of acceptable is 0.9, and not acceptable is 0.1. And then, or you have the first one's not acceptable, which means you have to continue and look for other ones that are acceptable. So the second battery, could be acceptable or it could be unacceptable. And then once you're here, you have to continue looking again because you need to put 2 in your flashlight. So you need to look again. Go through other batteries. The third battery could be acceptable or not acceptable. Or in this case, we have acceptable here or not acceptable. So you continue until you have 2. And there are different ways of having different outcomes where you'd have 2 acceptable batteries. So here we see that this is one of the outcomes, A. The other outcome, it's UAA. Or the other outcome, it's UAUA. Or the other outcome, it's UUAA. Or the other outcome, it's UUUAA or UUUAUA, right? So you will, the moment you get 2 acceptable batteries, you will add them to your flashlight. So there are different ways of getting to the 2 batteries that are working. Alright, so for P equal to 2, P2 means we're looking at probability that Y is equal to 2. And so we found 2 batteries. We've tested 2, found 2 that are working. Okay? And the probability of that is equal to the outcome, or having the outcome AA, where the first battery and the second battery are both acceptable. And so that probability is 0.9 times 0.9 or 0.9 squared. Why are we multiplying the probabilities? Because they tell us that the probabilities are independent. So we have batteries that are already manufactured, right? They're independent of each other. It doesn't mean that if one is defective, it doesn't mean that all the rest will be defective. So they're independent of each other. And so the probability here is 0.81. B, what is the probability that Y is equal to 3? So P3 is equal to probability that Y is equal to 3. Meaning we've tested 3 batteries. Once you've tested 3, from those 3, 2 must be acceptable. So 2 must be acceptable. Which means that, let us look at the possible ways. Let's say the first one was unacceptable, and the second one was acceptable, and the third one is acceptable. So you must have 2 A's there. Or you could have the first one was acceptable, second one not acceptable, but the last one must be acceptable because you need 2 A's. Your flashlight needs 2 acceptable batteries. Or you could have, that's the only different ways of getting 2 A's, right? Yeah, I know some of you will be asking, why is it that you cannot write AAU? I mean, you can write it, but in this particular experiment, if you have 2 batteries that are working, will you continue and look for another one that's not working? No, you have the 2 already, so you stop there, right? But now the question is, if we have Y equal to 3, meaning we did it 3 times, we looked 3 times, so we have 3 batteries in our hands. In this particular example where Y is equal to 3, we know that 2 batteries must be acceptable and the other one will not be acceptable. So this outcome here is not necessary because we will stop the moment we have 2 A's. So we have only 2 possible outcomes. Yeah, okay, so that's true. It says there that we only have 2 possible outcomes. There are 2 different outcomes. Okay, so now how do we calculate this probability? So a probability of UAA, right? Or AUA. Alright, so the or there in chapter 2 tells you that you need to consider the other possibility. It's either this or that. And so the probability is made up of all possibilities, right? So we're looking at probability of UAA plus probability of AUA. They're all independent, and so we do not expect any intersection of any of these events. Why are they independent? They told us that they're independent. So probability of UAA, what is that? The probability that the first battery is unacceptable, that's 0.1, times probability that the second one is acceptable, 0.9, times probability that the third one is acceptable, 0.9 again, plus probability that the first one is not it's acceptable, 0.9 times 0.1 times 0.9. And so this is equal to 2 times 0.1 times 0.9 squared. If I just simplify it, that is equal to 0.162. Okay, let us do another example. Let us look at P4. What does P4 mean? It means that we have 4 batteries. We've tested 4, and we have done this trial experiment 4 times, and so we have 4 batteries. And from those 4, 2 are acceptable. So remember, we're only looking for 2 that are acceptable. Only, not 3, 2 batteries. The moment you have the 2, you're good to go. You can put them in the flashlight and then look for the other 2. All right? So probability that y is equal to 4 means that, or we're looking at the probability that we will be looking or have, going through, these batteries, but we would have done it 4 times, where from the 4, 2 of them are working. So it means that if we've done it, if we would have done the experiment 4 times, it means that by the 4th time you would have gotten your last battery, right? If you're doing the experiment 3 times, it means that by the 3rd time you would have gotten your second battery, because you need 2 of them. So you will continue until you get 2 batteries. So the last outcome will always indicate the second battery. Alright, so let us have a look. If you have done it 4 times, it might be that the first battery might be unacceptable. So you have unacceptable, then you have acceptable, Okay, so you have unacceptable, then acceptable, then unacceptable, then acceptable. So you must do it 4 times. Then I have my 2 batteries there, okay? Or you would have done it as either the first one was acceptable, then the other 2 unacceptable, the last one acceptable. Okay? Or which other way? Oh, UUAA. Right? Okay. Is there any other way? UAUA, AUUA, UUAA. Okay. So you see that these are the only possible ways, right? Okay, so now we're looking at probability of UA, UA, or A, U, U, A, or U, U, A, A. And that is probability of U, A, U, A. That's probability of A, U, U, A. Probability of U, U, A, A. Gosh. So this probability then is equal to, so we come here, we have 0.1 times 0.9 times 0.1 times 0.9 plus 0.9 times 0.1 times 0.1 and 0.9 plus 0.1 times 0.1 times 0.9 times 0.9. That is equal to 0.1 squared times 0.9 squared. How many times? You'd have done it 3 times, right? So it's equal to 3 times 0.1 squared times 0.9 squared. Okay, so the same with C. If we have y is equal to 5, then what would be then the probability there? You follow the same pattern. So for P5, we're looking at probability of y is equal to 5. You follow the same pattern. So you would have done the trial 5 times. By the end of the 5th time, you must have gotten your second battery. So the moment you have 2 batteries, you're good to go. You can stop, put them in the flashlight, and then start looking again. Okay? So it might be that the first one, if you're looking at y equal to 5, the first battery is unacceptable, and second one unacceptable, third one unacceptable, fourth one, fifth one acceptable. Or you have U, A, U, A. Or you have U, A, U, U, A. Or you have A, U, U, A. Yeah, because you only stop until you get the last one. So you see that the last outcome should be your second battery. Okay, so if you would have done it 5 times, then the 5th one, it means by the 5th trial, you would have gotten the second battery that's working. So now the probability here is equal to, so I see it's 0.1 to the power 3 times 0.9 squared plus 0.1 again, 3 plus 0.9 squared plus 1 times 0.9 squared, and the last one 0.9 squared. So we see that it's 4 times 0.1 cubed times 0.9 squared. Okay, now D, they're asking, is there a pattern or can you get a general formula for your PMF? Yes, we can. So what is the general formula here? If I say derive the formula for your PMF. So have a look at the previous outcomes. So for P2, we said that it's equal to 0.9 squared. For P3, we said that it's equal to 2 times 0.1 times 0.9 squared. P4, we said that is equal to 3 times 0.1 squared times 0.9 squared. And then P5, we said that it's equal to 4 times 0.1 cubed times 0.9 squared. Do you see a pattern here? So this one, it's 1 times 0.1 to the power 0 times 0.9 squared. Is there a pattern? Yes, there is. So we could say that py is equal to, if we're just looking at formula for any y that is greater than, or from 2 onwards, we will say that it is y minus 1, right? So 5, we have 4 there. 4, 3, 3, 2, 2, 1. So if y minus 1 times 0.1 to the power, yes, y minus 2, right? So there you have 2 minus 2, 3 minus 2, 4 minus 2, 5 minus 2, times 0.9 squared. Okay, so we'll have py equal to curly brackets, it's y minus 1 times 0.1 to the power y minus 2 times 0.9 squared. If y is equal to 2, 3, 4, 5 onwards, and it's 0 otherwise. If y is less than 2. Okay, then that is your answer. Make sense? So it should make sense. All right, good.